stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause the stream is about to start. Get ready wherever you are, 'cause the stream is about to start. Hello everyone and welcome to another meeting of the C++ Digital Signal Processing JUCE study group. It may seem as though I am alone, but I am not. Hello Cwits, how are you doing?
Hello, I'm fine. How are you?
Good, good. And Tail is here on the chat. Hello Tail, how is everybody doing? Good, I guess. And Bo is here on the chat. Hello Bo, and hello Mage. Thanks for joining us. So, Cwits, you said to me that you don't have much to show. It always starts like that. And then you show us amazing things and you're like, maybe I'm considering turning this into a product or something. And we are always amazed by your updates. So, let's get you on the screen and you can show us what is up. So hang on as I press buttons real quick.
No worries.
Yeah, there you go. We see Ableton Live. Ableton Push. God damn it. We see Ableton Push.
It would be great if I can program Ableton Live on my Raspberry Pi, but maybe in the future. So what we see here, this is my sampler, where the sample is loaded in. We can hear it. What I have achieved for past 2 weeks. Let's select some, maybe range. It's some kind of bugging from time to time. It's still not finished. But what's interesting? Yeah, this sounds like original sample. I can press this button, move this thing a little bit forward, press this button a couple times, and the sample starts sounding differently. I can press this button a couple more times. Hi, Fotis.
Oh, Fotis just joined us. So hang on for just a minute. We will be without a sound feed, but I want to bring Fotis into the stream. So hang on for just a moment.
I don't know.
All right. So, hello, Fotis. How are you doing?
Hello. I'm very good. How are you?
Good, good.
Great.
So, Cwits is just starting his update. You didn't miss much. He was able to modify a sample by pressing a button. Can you tell us more about what's happening?
For now, sample sounds like this. Yes? You remember that if I press another button, sample starts sounding differently. Oh, something gone wrong. Sorry, guys.
Did it just turn
Something
off?
crashed. Yeah, whole application crashed, and there is written segmentation fault.
Oh no.
And yeah, no, it's not perfect. So I'm still working on this functionality, but I can, if we turn everything back, probably there will be some other sample.
Fellas, can we still do it? Yeah! How can we do it?
Where did you get these samples from?
How can we do it?
This is some random free sample pack from the internet.
Oh,
Okay, this is so long, I think, and we can try to make it shorter a little bit. Oppa, maybe a little bit more. Again, everything will crash. So, basic idea, what I have done. I have done some basic sample editing functionality, like copying sample, pasting, cutting, deleting, also reverse of the part of the sample. And yeah, something like that. I'm still working on it. As you can see, everything crashed a couple times.
Do you have a clue as to what crashed?
I don't know. I didn't check it still. So no, I have to.
How y'all feel out there? Check this out.
Check this out. Maybe.
I have never done this kind of manipulation to samples, but it seems as though it would be relatively straightforward. For example, playing something backwards, you just read the samples backwards. But are there interesting challenges in that? For instance, maybe some kind of representation for audio is something you can only traverse in one direction. There are codecs like that. I don't think that you would be using compressed samples, so you would probably not be running into that, but there are codecs that are easy to traverse in one direction, but hard to traverse in the other direction, or something of that sort.
I don't know such complicated words as traversing. What is that?
Oh, I just mean that there are audio formats, I guess video formats mostly, that are easy to play forward but difficult to play backwards, because it is like a linked list where each frame would be linking to the next frame in a way. Each frame would be just the difference between each and the previous frame. So if you want to play forward, it's easy. If you want to play it backwards, you have to reconstruct history, so it is kind of tricky. But I'm asking a broader question, if you ran into issues that were interesting to talk about.
I'm not sure. I'm not totally sure, because this functionality runs like basic copying buffers from one part to another, making another buffers, and just changing the pointers to the sound file.
I think that's
Yes.
check this out.
So yeah, it's pretty fun to mess around with samples like that.
Check this out.
And were you inspired by some Ableton Live instruments that do this? Because there are some really good ones, like even Simpler is pretty good.
But yeah, Simpler is pretty good, but to be honest, I didn't see similar functionality in the Simpler, like sample editing, like where when you can select some part of the sample and just copy that part and paste somewhere else. I have saw this functionality in Machine, I suppose.
Okay.
Maybe somewhere else, but I don't remember. I have inspiration about GUI part, about sample part selecting and zooming into that and stuff. From Ableton simpler, yes, because I really like how how push is taking those. I didn't know how they made this. Sorry. So yeah, a little bit from there, a little bit from here, and how it's done.
All right. And do you know what you want to do next?
I totally will continue to work on this because it's still not finished. Yeah, I have to figure out why I have those segmentation faults.
Why it's crashing?
Yeah, why it's crashing, and I want to finish the GUI part because it's still not so good as I wanted to see it, and there is still things to improve. So I definitely will continue to work on that.
All right, all right. And do you have a plan as to when people will be able to try it out for themselves? Maybe not open sourcing the code, since you have this idea that maybe you're going to turn this into a product, but you can always share, I guess, the binary for people to play around with.
Probably, I was thinking about it, and probably after I will done first rework of all my code. Because for now, all code is total mess. I'm using different code styles in different places, and I'm not sure that I want to show this to the other people. And there is things to optimize and to work on them. I hope I will finish it till January of the next year. I hope. I totally hope. Probably I'll hopes will.
Given the pace of your updates, I think you are going to be on mark with that.
So yeah, somehow like that for now.
All right, all right. Do you have other things that you would like to share?
No, totally no.
All right. Well, that is, as usual, very impressive that you have all the user interface with the lines showing the playheads and everything. It is really nice to see what you're up to. And what do you all think of me going next?
Well, I can go next.
Oh, okay. You go next then.
Time for me to share with you my adventures and misadventures with HISE. So I created the synth, but I have run into a massive bottleneck that not even the HISE guys know how to fix. And it's a rogue MIDI node that's like a ghost. It's like my laptop has been possessed and it's sending one note. I'm gonna show you, but I'm going to turn down the volume because it's very painful to listen to. First, I'm gonna show you the synth itself, what I created, and then I'm gonna run HISE and show you what I did and show you the problem, and maybe we can fix it together. I don't know.
Well, so we can certainly try.
Yeah. I'm gonna run Reaper and I'm gonna share my screen with computer sound.
I forgot one thing, that all those manipulations on the sample I can do while something is playing. That's, in my opinion, is most interesting part.
Yeah, live manipulation.
Yeah, because not all DAWs allowing that to do. Probably, maybe I'm wrong.
I know that, of course, Ableton Live would allow you to change samples live, but I don't know about others. I would expect that some DAWs are more oriented towards recording, like Logic, but I'm not sure. I haven't played with that?
Probably I also can confirm.
I once watched a very early talk by Justin Frankel, and he explained that one of the reasons he wanted to do Reaper, to build Reaper, was so that he could change stuff while the recording was going on. So you would be able to create tracks, ARM tracks for recording and that kind of thing. I think that these days every DAW allows you to do that. I'm not sure. I haven't tested, but it's just one of those things that it is tricky. It is not trivial. It may seem trivial when you are using it, but it's not trivial when you're trying to implement that.
To be sure, I was playing a couple times with my friend. He was using, I don't remember what, but I was using Reaper to play music. No, we was jamming, just random things. And not always Reaper allows to modify something while it is recording, especially when record become too big. For example, if you're running in a loop and then you have the, I don't know, 70 parts of the recorded stuff, then it becomes a little bit tricky to modify, and you have to press stop and play again.
Oh, really? I don't remember running into that kind of thing. I guess my projects are not so ambitious.
No, it just was playing around 2 hours from the beginning, and there was a little bit problems after that.
Interesting to know. So, Fotis, what are we looking at?
I'm just updating my repack. One sec. Oh, Skype is running too. No, sorry. It's a different window. One sec. Okay, no updates to repack. So first of all, I'm gonna show you my my humorous GUI. So are you ready to see my very first synth?
It's not your very first. Well, I guess the other one was more like a sampler. So
it was a sampler. So here it is.
No, it's real cool in my opinion.
Can you hear it?
Yes.
Yes, great. So it's a simple saw. You have a graph here. I followed David Healy's tutorial on how to do it. You can't edit the graph, it's just a visualization. It's just an ADSR envelope.
And is this a component that comes with the framework, or did you develop this from scratch?
No, it does come with the framework. You just have to tell it to... It has a graph... where is it? I think it was the floating tile. And then you have to tell it to be the AHDSR graph.
Okay.
Or you can do more things with it. For example, it can be a keyboard. Anyway. So the problem is I'm going to turn down the volume. Sorry, but my microphone has a lot of drivers. But
sources do you have?
Yeah, all of these are the microphone, the Elgato. It has a built-in mixer, and even you can plug headphones on it. Anyway, I'm going to turn down both Reaper and HISE because the problem happens in both. So first, let's go to Reaper itself, and instead of pressing the keys on Reaper, I'm going to play the GUI. Did you hear it?
Yes.
So, was it too loud?
Well, not too loud because you attenuated it, I think, or
Okay.
maybe Skype did. I don't know, but it was annoying because it was very high pitched.
Yeah, that's the problem. So let's go to HISE itself. And 1 sec, I'm going to load the project file. So it all started when I went to this graphical keyboard and I pressed a note. And the same problem persists. If you look at the GUI, look at this place. Do you see this note? This specific note is stuck. And I have no idea what is triggering that note. I actually plugged a MIDI keyboard and I played with it and I had no problems.
Hang on, are you saying that there is a problem with that note specifically, or that any key on the keyboard would trigger this issue?
Any key.
Ah, okay. For a moment, I was thinking like, no, it's only F4 or F5 or whatever this is that triggers the problem.
Yeah, and I created a thread on the HISE forum. I sent the snippet to David Hill. By the way, this is an interesting feature of HISE. You can actually export your whole project as a block of text, which is this one. So David Healy copied and pasted this and went to import HISE snippets. So he was able to load my own project.
Does it come with just the interface and the controls, or does it come with the samples and everything?
I don't know. I sent it before I created the GUI, actually. He said no problem here. You have a MIDI keyboard, and I just plugged in, and I didn't have a problem. So it only has with on-screen keyboard. And I sent him this screenshot. So, help.
Well, first thing that comes to mind is, why do you need the on-screen keyboard? Why not just get rid of it?
Yeah, I can get rid of it.
Why?
The problem is that I needed to test the sounds. So I don't want to have to plug in my MIDI keyboard all the time. I can get rid of the GUI, of course.
No,
but
only
in HISE testing...
Keyboard.
Sorry?
Only from keyboard, not all GUI.
Yeah, I can get... Sorry. I can get rid of it in the... Boom. So if I recompile the plugin, it won't have it. Okay. But still, I need something to test it, you know?
And you don't want to have a MIDI keyboard, because having that is annoying. But you could just have some sort of app. Maybe Reaper can do that, but if it cannot, I'm sure there will be some kind of app that is an on-screen keyboard that sends MIDI that other software can get.
Oh, I could actually use a loop MIDI now that I think of it. A loop MIDI is a driver, and I could direct MIDI from Reaper to HISE. So basically,
there you go.
Reaper itself will be my on-screen keyboard.
And also, if you don't want to always have to go to another app and click around, you can have a short MIDI item in Reaper that you loop, and always there's always some notes coming through. So, and I guess from a user's perspective, I don't love the on-screen keyboards on plugins. I find that they take a bit of space. They are too small to be functional anyway. And if you're trying out, you're like auditioning for an instrument, you tend to want to play the thing that you are thinking about, not just click on random notes. And if you're playing the thing you're thinking about, it's very hard to do with the on-screen keyboard. So maybe you already have the MIDI item, or you have a controller in front of you. So that's why I asked if you could get rid of the keyboard, because I don't like the keyboards on these plugins. It's just taking up extra space.
Yeah, you're right. And I think it looks more modern this way without the keyboard. So yeah, thanks for the feedback. I'm going to leave it out.
Yeah, but again, I guess it would be interesting to know why that is happening. So one thing that could be the issue is that your MIDI controller and perhaps even the on-screen keyboard on Reaper are sending the note off events with... There are two ways to send a note off event, and maybe the controller in Reaper is they are doing it in one way, and the on-screen keyboard from HISE was doing it in the other way, and then for whatever reason, it was not recognizing its own way of doing things. But there are two ways to send a MIDI note off event. One is to send an actual note off, and the other is to send a note on with a velocity of 0. So maybe that's why, and the note off would never be processed.
I don't know, but this happens even when the Reaper is turned off, when all I have is HISE. So there must be some kind of process. By the way, I have a driver installed. I don't know, maybe this is causing the issue. It's called OmniMidi. I'm gonna try uninstalling it and see if that's the root of the problem. OmniMidi is like a driver that you can use with the sound fonts and whatever.
And do you think that maybe there is some kind of logger in HISE? Because in Reaper there is this recontrol MIDI effect that has a logger of MIDI events coming in. If HISE has something like that, that you can see the MIDI events as they come, then you could test my theory that the different keyboards are sending the note off in different ways.
That's a great idea. I should look about a MIDI logger. There must be some kind of way to do it. I mean, HISE has its own language, so maybe I could write a script for that, I guess. But yeah, this is the MIDI processor.
I think about two things. That first one is that this is HISE problem. And the second one, did you write some code by your own?
No, I didn't actually. I just
used
only for the GUI. But the problem existed even before I created the GUI. And also, one thing to note is that this problem also happens with another VST, not mine, a free VST called the UVI workstation. It's like Contact. But yeah, I have noticed that when I run it, sometimes the same note is stuck in there. So it's probably something else.
Yeah, and Bo is suggesting something. You could try different DAWs because Reaper note off commands works in mysterious ways. So there is that. Maybe the on-screen keyboard is... Well, I guess the weird thing is that it is the on-screen keyboard created by HISE by itself. So why would it not recognize its way of sending note offs? But yeah, MIDI note offs are weird.
Yeah, and also maybe... oh yeah, now that I think of it, Loop MIDI itself has a logger. Maybe I can run it. There it is. Oh wait, what? But I have it installed. What? Is it trolling me? Oh, okay. So let's root loop MIDI. Oh, there it is. Cancel. Yeah, save, sir. Doesn't seem to be getting any data. Strange. What if I do this? Nope.
Yeah, I guess it's not picking up anything because it's not going out of the software that you're using.
Probably.
If you tried to do the Reaper as the sequencer and HISE as the, I guess, the client, then perhaps that would work. That would show events.
Okay. Okay. Let's try it here. MIDI. The problem is that MIDI in general works in mysterious ways. This menu is the most mysterious thing ever made. Oh my God, I hate it.
Why?
I don't know. So can I enable it? Yes. Apply. So if I press a note, no, it's not receiving. What if I create an
Because
empty
you
MIDI?
enabled input port. This is for incoming
Oh,
to
yeah.
Reaper messages.
Sorry, yeah, you're right.
You have to enable output.
Yeah. There is the output. Yes. Enable.
And then send to, like, press route on the Reaper.
Oh yeah, MIDI and all
this
out.
is also input. You have press route.
Oh, sorry, yeah. The output is here in route.
Yes, and MIDI hardware. There should be. No? Why?
No, it's not. Should I restart Reaper or something?
I'm not sure. You can try to reset all MIDI devices, because as much as I remembered, everything.
It's receiving. 192.
And try to route now.
Yeah. Let's go.
It bugs me that you close the preferences pane with the close button, not with the apply button.
Yeah, it doesn't.
Does it apply the changes?
It does, because they are enabled here. Nothing changed.
Yeah, I guess you are right.
Anyway, let's press. Whoa! Whoa, 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 whoa! So, oh my God.
Something gone wrong.
But the setup works. You are able to use Reaper as the sequencer to test things without needing to connect your MIDI controller.
Yeah. The thing is that I daisy chained Reaper to HISE because we did this. We used loop MIDI as support. So yeah, we did the most horrible thing in the world, but it works. So in order to save your ears, I'm gonna stop these experiments. So instead, I'm gonna talk a bit about the GUI. First of all, that's not me. That's not a picture of me. This is a 3D model. My dad created a photogrammetry model of myself using an app called Kiri, and this is a composite of the 3D model, both the texture, the mode, and the wireframe mode, and I just place them together. And the Kiri allows you to get a high poly and the low polygon model, and I use the low polygon because it makes me look like a PlayStation 1 character, and I like it.
It is very creepy. It is very creepy.
Yeah, it is. Obviously, this is not going to be a commercial product. I just wanted to have fun, you know.
It could be. You probably know of the freak show industries.
Oh yeah, of course. Yeah, I love those people. These are crazy. I mean, even the installer is full of Easter eggs and jokes. So yeah, I could make in a month, Halloween is approaching, so I could create a horror themed plugin. And also the background is from a shader toy. I forget who made it, but if you go to shader toy and look for synthwave, you'll find it. Thank you, person who made it. But yeah, so one thing that I want to say some final things about HISE, because despite this MIDI problem, I really like it, and thanks to David Healy's YouTube tutorials, I'm really starting to get the hang of it, and I'm learning just a little bit about the scripting. For example, where was it?
The language is not an existing language. It is a language of HISE itself.
Yeah, it is. It is based on JavaScript, but it has its own modifications. Just like JSFX language, EEL is an offshoot of C, right?
Yeah.
I forget where did I place script. Oh, here. So this is just a variable, but you have to type the name of the envelope that you create. Otherwise, it's not going to respond. And also, this is a nice trick that David shows in his video. The menu takes a little bit time to get used to because it's so layered.
Yeah, that's the impression I get anytime you show this. This thing is so complete. There is so much in here.
And also, this is the nightly that came out 2 days ago. I still update via GitHub. Anyway, so this is a little trick that uses the mod wheel to adjust the intensity of the LFO. So if you go to MIDI controller, you can adjust this, and now the LFO itself is behaving. You can see that it's jumping. But if you go to the MIDI controller and you turn it down, it should have stopped, but it didn't. Oh yeah, now it stops, yeah.
Yeah.
But you can control the intensity of the LFO just by tweaking the mod wheel. And you can use a CC number. David suggests you use 94 because it's not used by regular applications. And also you have the hold, which is in the ADSR. It's HDSR. And also you have sends. You have to create a send effect, and it sends to a send container. It can contain where up to this channel allows you to route up to 8 stereo buses. So you can have 8 effects at the same time. And if you want to create more effects, then you have to create a second send container. And with this pencil, you can see what's happening, and it's amazing. Also, one final thing before I wrap this up is that, where is it? Oh yeah, in MIDI processor, you can actually have small scripts. And this is something that David Healy says in his tutorial, that HISE is different from Contact because Contact scripting language forces you to work in just one script window. So your instrument has to be this huge block of code. But in HISE, you can create a small script processor. And so you can have small scripts inside the instrument, inside the plugin. So you can have many things. So if one thing breaks, it doesn't mean that the whole code will break. You can have sub-programs.
Well, I don't know much about Contact, but it stands to reason that they have some sort of abstraction. If not this kind of sub-programs, they would have subroutines, they would have functions, they would have procedures, methods, whatever. But they would have some sort of abstraction to localize code. And as far as like having one big window versus many small windows, I guess if you're doing anything big enough, you're probably going to be using a text editor, something like Visual Studio Code, and copy and pasting like I tend to do with JS effects. But anyway, I get behind the idea that they are trying to give more structure to things, and I like that.
Yeah, it's very flexible this way. Because I've seen some Contact libraries that this is an actual developer's quote, that they created an engine inside Contact because they wanted to create a looper engine inside Contact with their own effects that they scripted themselves. I think the developer was Rigid Audio. I think I saw it on Plugin Boutique, and the engine is like 20,000 lines of code. And so if you're running the Contact, you're actually running the engine on top of Contact. So it's like a pyramid of scripts, you know. And I don't know, I think that's a little bit That's a little like you're hogging your CPU like this. You're loading the entire thing. So maybe in HISE you can get past that, and you can actually, with these little script things, the user can actually enable or disable the scripts depending on their actions. So not only they don't have to run the entire 20,000 lines of code. You know what I mean?
Yeah.
It's like they're muting and swallowing code.
Okay. Sounds interesting.
So, yeah.
Dale has some suggestions here. He also said that never mind. But anyway, I suggest that you go to the YouTube chat to understand what he's talking about, because he looked into the source code of HISE itself and into the thing that implements that on-screen keyboard. If you are still interested in knowing why that was happening, because you may want to contribute back to the HISE people.
Sure.
But he found a place that is suspicious looking. It is sending a node off with a value that is not 0. And usually you send node offs with a velocity of 0. But in that case, it's not.
Yeah, I could.
Anyway,
I could look into it. Yes.
Yeah.
So I'm gonna stop sharing my screen. And yeah, because like I said, the same issue happens with UVI workstation, which, as far as I know, is not created with HISE.
Yeah.
So that's weird. It's even weirder.
Yeah. All right. So
computers are stupid. This is the point of this stream.
So it seems like you got over this roadblock, and now the next thing is to do what exactly? What's your next step on this instrument?
I want to actually create an effect plugin with HISE. You can do that in the export options. It gives you the option to create an effects plugin. And I want to create something with the built-in filters. They have reverb, low pass, high pass, etc. And I would like to create a filter just with a GUI of my own, not that creepy as the previous one. But I want to test how I would approach a GUI to an effect plugin. And also I want to test the convolution reverb that comes with HISE, because it's using this. I said that in a previous meeting. If you want the full potential of the convolution reverb, you have to install a separate dependency called the Intel performance, whatever it was called anyway.
IPP,
so,
if I remember correctly.
IPP, yeah.
But yeah, these people have everything. It's very complete. It's really impressive work.
And it's getting more and more complete every day.
Very nice.
Yeah.
All right. Looking forward to hearing from you again on the next meeting. Do you all want to hear what I have been up to?
No.
Yeah.
Well, to be fair, we are on the C++ study group, and only Cwits is doing C++ here. Fotis is doing HISE, which is a flavor of JavaScript when it gets to the coding part. And I am doing electronics. But hey, I'm having a lot of fun, so I would like to share what I have been doing in the electronics world. So let me start to share my screen, and this is the janky setup that we have for me to have a second camera. It is ridiculous, but it's lag-free. See? Isn't this amazing? For people who were watching my last live stream on electronics, you know what I'm talking about. It was a whole mess. But anyway, here is a secondary camera. And my son is getting, his birthday is coming up soon. And we are doing this as his gift. And it has a little bit of everything. It has a light that turns on, and it has a plug for him to play with. And I wanted to include something that made sound. So we got this turtle. We made this turtle. And it is not super loud for obvious reasons. I don't want to give a 2-year-old something that makes loud noises, but it is an oscillator.
Wow.
Okay.
And I want to share with you all the circuit that is in the turtle. Of course, the knob that you turn is an unicorn because he likes unicorns. And this is a ridiculously large button. It is one of those buttons that people put on power tools. But anyway, this is the little turtle. And what's inside the turtle is a super nice little circuit. It is probably the simplest oscillator you can make in terms of the number of components that goes into the circuit. And it puts a
Let me
component to
guess,
use,
Leandro.
in a way that is not intended. So it is a super cool little circuit. What did you say, Fotis? I think I heard your voice.
You hear
Oh yeah,
mine.
it's a modular birthday gift.
Yeah, it's a whole board, and there is more stuff. Like there is his favorite wheel and little cars and everything. There's a lot of things here. There's a little door and these kinds of locks that he likes to play with. And the
very
plan
cool
is
game.
that we will be changing stuff on the board as time passes.
Leandro, let me guess. The schematics is based on the 552 microschem, or
I think you're thinking of the 555.
Yes,
And the
yes.
answer is no. It's even simpler than the 555. And yeah, so this is the whole build, but I also have the prototype. Well, actually, I had a prototype that I took apart when I was making the thing. So I built the prototype again for the stream. So hang on as I bring the prototype into the view of the camera. This is the little prototype. And as you can see, there is not a lot going on here. There is a little push button, and
Wow.
that is just so that it's not making noise at all times. And the speaker here is much better than the tiny little speaker we need to put on the actual project. And then there are just a few components here, but here is the schematic for the thing. And this is an essential part of the schematic. It has to run with a relatively high voltage, 18 volts in this case. So I just put two 9-volt batteries in series. And it may look a bit strange here, but it is the kind of setup that many devices have where you put two batteries, like one is upside down with respect to the other. That's just so that they are connected in series, and then their voltages add up. And this is what we have here. So the plus of one battery is going to the minus of the other battery, and then you use the plus and minus that are not connected, and that gives you 18 volts right here. And this will be necessary because we will be exploiting a component in a way that is not supposed to be done. And that only works if you have a high enough voltage. It's still not like 220 volts, but it is relatively high when it comes to these kinds of things. So there is the little switch here, and that's, again, just so it doesn't make noise all the time. If you wanted, you could, I guess, not have the switch and then take the cable out and back in again. Then you need to have some resistance. The exact value will change the pitch. So I just put here on the schematic, it probably you want it to have it greater than 1 kilo ohm. Because otherwise, and I tried it, if you probably don't want to do this to fancy, expensive speakers, but if you have lower resistances, even if you approach 0, the speaker just pops out and stops. Oscillation stops, and the speaker is just stuck. Luckily, this one didn't break, and it is remarkable that this is a €1 speaker, and still it was robust enough when I was abusing it. Anyway, and then there is a little capacitor here that is this guy. And you may remember from my previous streams about electronics, even on the study group meeting, that if you have just this resistor and capacitor in this kind of arrangement, then what you have is, do you remember what this is?
Of course.
Of course.
I know what is this.
Do you remember, Fotis?
You mean the breadboard?
Yeah, they're here in the breadboard. This resistor and this capacitor.
Was it the low pass filter?
Exactly. This is a low pass filter.
Yeah.
So the way that I like to think of this is that if you don't consider this part, just think about this part, is that when you turn it on, so when you press the switch, what happens in the capacitor is that to begin with, it is not charged. So let's say that the charge is over here. And then as time passes, this resistor doesn't allow the capacitor to charge super fast. So what happens is it is like a curve that goes up. Oh, not this way though. I got it wrong. It starts uncharged and then the curve looks like this. It bends this way because the more you charge the capacitor, the harder it is to charge it. And at some point, it will stop taking energy. It will stop just saying, okay, I have enough. I am charged. And then it goes like this until you release the button. And then it happens the other way around, where it starts discharging fast and then more slowly. This kind of curve. And I guess if the original input, when you are feeding electricity to the system, just looks like this, when you press the button, it goes to 18 volts. And when you release the button, it goes back to 0. Then this is the shape of a low-pass filter in the time domain. But that's not all that exists in this circuit. There is also this part, which is just one other component besides the speaker. And you can treat the speaker as sort of like measuring voltage, I guess. You could put an oscilloscope instead of the speaker. You could put an LED instead of the speaker, as long as you adjust the values of resistors and capacitors and even the voltage source. But this will be just to measure the oscillation. This is not really making the oscillation happen, so to speak. But anyway, so there is this part to the circuit, and this is called the reverse-avalanche oscillator, and some people know it by some other name that I forget, Ezaki, something like that. So if you're interested in knowing more details, you probably want to research about reverse-avalanche. But what's happening here is just this other component, this one other component, which is this transistor right here, this guy. And the typical way that you are supposed to use a transistor is that electricity is supposed to go in this direction. And it may be hard to see on my drawing, but there is an arrow here pointing up. So usually electricity likes to go in this direction, from bottom up, in the direction that the arrow is pointing. And typically you use this middle leg. It may be hard to see on the camera, but there are 3 legs in this component. The middle leg is, roughly speaking, to say how much current can go, how much electricity can flow through the transistor. And in this case, the middle leg is cut off and the transistor is backwards. The arrow is pointing in the reverse direction of the electricity. So what's really happening here is when we get somewhere around this region. Oh, sorry, I should explain what happens before. Before we get around this region, so at this point right here, this transistor is backwards, so it is not conducting. So in essence, it's not present in the circuit because it's not conducting electricity, it's not part of the circuit. So to begin with, the sound that we would hear would be something like this. Or actually not. At this point here where the speaker is connected, there is no electricity flowing, so I guess the sound would be something like a flat curve, a flat line at 0 volts, because this point in the circuit is not receiving electricity, and this is connected to ground. So it would look something like this. But then at this point, something interesting happens, and that's why we need to have a high voltage on the source. What happens is that this transistor is supposed to stop electricity from flowing, but at some point it breaks down. It's no longer capable of stopping electricity from flowing in the wrong direction. It gets into this so-called avalanche or reverse avalanche mode. And what happens in the reverse avalanche mode is that it starts to conduct electricity, even though it was supposed not to. But we are sort of exploiting that property in this oscillator, because what happens in that stage is that electricity starts flowing through the capacitor, the transistor, in the wrong direction, in the reverse direction, which means that we will start to hear something because the speaker is in the path. So immediately when the reverse avalanche starts, we hear a spike right away, because now electricity is flowing. We got into this reverse avalanche region. And this capacitor that usually would just say, okay, I am charged. I don't need more electricity. I had enough. Well, in that case, because there is a path from the capacitor to ground, it will start discharging. It will have a way of, not to ground. There is a path from the positive to the negative. That's what I wanted to say. So now there is a circuit here. So the capacitor will start discharging with this kind of curve. And then at some point, the transistor will get out of the reverse avalanche mode. So I guess it starts the reverse avalanche mode at one point, and then it is in that mode for a little while. I guess that's what you would call hysteresis. I'm not sure. But the point where it breaks down and the point where it recovers from reverse avalanche mode is not exactly the same point. And that's this difference from the bottom to the top of this curve. But what happens in this case is that, okay, so this door has closed, and that means that the capacitor will start recharging, because supposedly you're still holding down the button in this part. And then the cycle repeats. And what you get is sort of a triangle shape. So with a classic oscillator using a 555 chip, you get a square wave, and with this one you get a triangle. And this uses even fewer components, and it's exploiting one of the components in a way that wasn't intended. So that all of this was a lot of fun for me to learn about. Is this something that you knew about Cwits?
I'm not sure. Actually, very great explanation from you. Thank you.
Oh, thanks. I'm just learning this myself, and there is a great video by Luke Mumnon Computer that it shows this circuit. There are actually two, and in one of those, he is building a circuit very similar to this, not quite the same. He has a couple other things going. For instance, between the transistor and the speaker, he puts a resistor here because he does some mixings. He builds many of these and mixes all of the oscillators together before sending them to the speaker. And in some other circuits, you may find like an LED here in the middle. I found that this is enough through experimentation, and I also found some circuits online that this is enough. It oscillates. And another thing that I played around with, and there are some other websites explaining these kinds of things, is I played with different transistors. If you look at the Luke Mumnon Computer video, he's using the 293904, and that one worked for me, but the range wasn't so great, and it was very hard to make it oscillate. I mean, I would have to lower the resistance a lot, or increase the resistance. I forget. The knob would only work on one side, and most of the range was dead. And it would also be super high pitched. I don't know about that. It was super weird. So I tried a couple of them. I tried I tried all the transistors of the same type, all NPN BJTs that I had. And what I learned is that the 2N39, is this something I can show? Yes, this is just some Amazon Basics 9-volt battery manual. So the 2N3904 worked, but it was super annoying. The BC547 worked nice. The BC337 was okay, not as nice. I mean, in terms of like the range and the sound and everything. And the one that I'm using here is my favorite. It was the BC517. And I also tried a high voltage one, the BD139, but I think that my voltage source was not enough. 18 volts was not enough to make that one oscillate. So BD139 didn't work. So if you're trying this out and you are going to buy a transistor, you can buy any NPN BJT that most of them will work. Some people online said that you may find a batch that doesn't work or that some may work better than others, but almost everyone that I tried worked. And some people like Sam from Look Mom Non Computer said that you have to cut the middle leg of the transistor. I just plugged it into the breadboard and it worked. I even, just to play around with this, because I wanted to do some electro boom kind of stuff, I reversed the polarity of the capacitor because I'm using an electrolytic capacitor, which I'm not sure is the best option for this circuit, but that's what the one I used. And I inverted it and it still worked just fine. It didn't blow up, so no electro boom from this voltage source, I guess. Anyway, another thing that I played with, and this is something that I think is super cool, is with different ways of setting up the resistor, because changing the resistance with a knob is cool, and that's what we did in the final project. But it is also cool to use one of these guys, which is a light dependent resistor, or LDR. And then it works like this.
Oh, it responds to light sensitivity.
Yes, the darker, the lower the pitch. So
Wow.
it's fun to play with like a light. I was using the light from the phone, which of course I cannot right now. I guess maybe I can. Can I? Can I turn on this thing? Is it on? It's not on. I cannot use the camera as well as the light simultaneously. Anyway, it's super fun to play with the light. And that's another thing. If you're going to do it like this, I suggest that you get a very high intensity kind of light source, because otherwise you cannot get high pitched sounds. I mean, this is relatively low pitched. And even for the 2N3904, when I tried it on the circuit, it would not oscillate unless I had my flashlight pointing at it with this kind of resistor. And just as a final one, I'm gonna just throw this in there because I thought it was so fun. You can just pencil in a strip of paper, and that is conductive because carbon is conductive like that. So a pencil can make a line that is conductive, and then yes, that's where it's supposed to go. And then you can play it like this. So for this one, I guess you wouldn't need the push button because I'm just holding it down anyway and I'm pressing this. And there are people who like draw these little keyboards on paper and they tune the keyboard by just letting the oscillator play and probably put some kind of tuner. And then they start drawing more and more because the heavier the line, the more conductive it becomes. Or you can also shave some of the graphite off and it becomes less conductive. So yeah. Oh, and by the way, if you wanted to know, this is what happens when you short circuit the thing. So when the resistance becomes 0, the speaker will pop up, which you may not be able to see because you have a perpendicular view, but yeah, it just pops up like. And that's my update. So moving forward, cool. I will probably try to do some fancier oscillators or something like that. Maybe I will get into the DIY oscilloscope using the sound card thing that I always bring up but never end up doing. So yeah, that's what I am
Leandro,
planning
I
on
have
doing.
a couple questions. I have a couple questions.
Yes.
First of all, how fast battery is discharging? Did you tested it?
I didn't test, but I have been using these
Because
batteries for experimenting, and they are still okay. I haven't measured, but they are probably around 9 volts still. And I would guess that they're not discharging too fast. One of these two batteries I'm also using, you probably saw that there was some Velcro on it, and that's because I'm also using on another little project that I made, but this one is not super interesting. I just hooked up a little circuit I bought from Amazon that is an LM386, a power amplifier, and now it is a little speaker I use on my phone. But so that battery is being used on this other thing, so that thing is also consuming some power from it. But it's not discharging too fast, I don't think. It seems to be reasonable.
just as I remember, those batteries, especially 9 volts, are not the cheapest ones. So if they discharging too fast, it would be a little bit. I don't know how to say that. Not good.
Yeah, I of course also played with things like what happens when you short circuit the batteries and that sort of thing. And when you short circuit them, they discharge fast. But then again, what do you expect, right?
Yeah, of course.
Yeah.
And the second one is not like a question, but more like idea. I just don't know what will happen if do that, but still, if you can put light source in parallel with the speaker and use light dependent resistor instead of potentiometer, will it self-oscillating?
Probably. I heard that
interesting
there
to
were
experiment.
some DIY LFOs back in the day that used this. One thing that I did try, however, is I was doing another electronics-related project that had nothing to do with music. It was a light that is dimmable when we are putting the baby to sleep. So in that case, we had an IKEA light. It's a night light sold by IKEA that is LED and an LDR. It only turns itself. It's just this small little thing that you plug into the wall, and it will turn itself off when the lights are on. And when you turn off the lights from the room, it will detect that it is dark now, so it will turn itself on. There is no switch on the thing. It's just this LDR. And what I did is I put two mirrors in a way that would point the LDR at the camera, at the light source, and it self-oscillated. That was so fun.
So cool. But I think you can try this idea with this thing. Maybe
Yeah, I think it will be more like in the LFO range, though an LED is capable of fast responses, but I think that it will be more like an LFO kind of thing. I don't think we would hear that kind of oscillation.
Maybe also,
Yeah.
By the way, in the chat, I posted the link from the Air Windows YouTube channel. It takes you to a search for the word DIY, because last year Chris made a series of live streams where he created his own synths from scratch. So maybe Leandro could take some inspiration, because that thing he did just now with the light, when he crossed his finger and did this, Chris created a synth that made almost the exact same sound. I don't remember which one it was, but maybe you could get some ideas from his DIY live streams.
Nice. I didn't know that he was doing electronics as well. I only knew him from the plugins. Right.
Yeah. And also he was... fun fact, when he was doing the Patreon rewards, he was considering sending circuits and wires to people. But people were more interested in Chris buying hardware that he could emulate as opposed to creating their own synths. So the people have spoken. But yeah.
Oh, I forgot about one of the resistance mechanisms that I forgot to show. I wanted to show you this. So hang on.
Sure.
Let me share the screen and back to this setup. So the last resistance source is myself.
Yeah, that's all.
So you can barely hear this one. It's just clicks because my resistance is too high. So for this to oscillate on a higher pitch, I would probably need to change this capacitor to be, I want to say smaller, because the resistance is higher, so there is less current going through, which means that it will take longer for it to charge, and that makes the pitch lower. So I would put a smaller capacitor. This one is 10 micro. If I went with something smaller than this, it would oscillate higher. But this is so fun that you can be a source of resistance. And I saw some people online using like a watermelon and sliding cables around the watermelon.
Yeah, foods are also cool.
But I thought it was cool that we can be the instrument like that. And another thing that I wondered when I saw this circuit is that, oh my God, it is so simple. Why can't I just turn this into something playable and just adjust the resistances to make it like play notes on the scale? And what I think happens, and that's, I don't think why people tend not to use this circuit for like synthesizers, is that as far as I understand, this circuit is not voltage controlled, but current controlled. The rate of the oscillation and the pitch are controlled by the amount of current consumed and delivered by the capacitor. But in something like an oscillator for a synthesizer, you want that to be controlled by the current, by the voltage. Why that is, I am not 100% sure I understand. I don't know why people prefer to control things by voltage, but that is how almost everything is controlled by, from synthesizers to motors or anything you can imagine. So people tend to prefer to control things with voltage, and this is difficult to tune when it comes to the voltage, because in this case, for instance, the voltage is always this same voltage right here. So it's difficult to tune, and I would expect that it is not great in terms of maintaining pitch as you warm up or cool down the transistor, because I suppose that in normal use of a transistor, it will change its properties as you heat it up. And I expect that in the reverse avalanche mode, that will also happen. So it is a cool little circuit, but it is mostly a noisemaker. It's not really a voltage-controlled oscillator that you would put in a synthesizer for this reason. It is difficult to control and to maintain pitch. But it's so cool that something as simple as this, something that can go in a little turtle, can make sounds. And yeah. And I do want to address some questions we have here on the chat. Mm-hmm. They may be out of date at this point, but let me comment. So Bo is saying low pass filter. Correct. You were correct. The resistor and the capacitor formed a low pass filter. And is that NPN transistor hooked the wrong way around? Yes. And yes, Tail is saying that it is a pretty smart circuit. It is. I really like how clever and simple it is. By the way, I think you can also use a forward avalanche effect as a noise generator. I think you can, yes. And is that a log or a linear potentiometer? This one is a linear one. Probably a log would be better because pitch is logarithmic. Yeah, and Tail is commenting on the little stylophone kind of thing. And Bo is saying that by December, I will have built an LA two-way. Probably not, because I don't want to get into valves. Not interested in high voltages. I think they may be dangerous for someone like me who doesn't know much. But I think it would be interesting to do some optical compressor. So the LA2A is an optical compressor, and most of the character comes from the amplification part of it that is based on valves. So I'll probably not do that, but I can do something like the OLA5, I think, is the name of the DIY recording equipment optical compressor that is not based on the LA2A, it's based on a descendant of that, I forget which one, but it is an optical compressor followed by a typical op-amp amplifier. And that's something that I may do because, again, the reason why I wanted to get into electronics was to do a vocal chain that is completely analog. And I think that would be interesting.
By the way, I posted a tweet from Matt Title, the creator of Vital. Can you please show the tweet? Can you load it on your browser and show it on your screen?
Yes, I'm opening that. And Bo is answering my question. I think that the voltage control was a standard that Robert Moog started. It was the easiest way to communicate between different synths and pre-MIDI. That is true, but my question is, what is it about voltage that makes it easier to control than current?
Maybe that's the whole basis that modular synths are based on, right? They're using CV control voltage.
Yeah, and that's what Robert Moog pioneered, I think. But why voltage? What is it about voltage that makes it easier to work with or better to work with? I don't know. Anyway.
I guess it just works.
It is something for me to learn and share with you all, but you wanted me to share a tweet.
Yeah. You know who Matt Title is, the creator of Vital? He did an experiment where he became an analog synth. He had electricity on his own arm. It's crazy, right?
It is crazy. I mean, was he like doing some kind of exam or something, or did he do it for fun?
For a friend. I think a friend of his was doing a medical experiment, so Matt volunteered. He explains it in a tweet below that.
Okay.
Yeah.
I will link to this in the notes for the meeting.
And you can also you can also link to the Air Windows DIY videos that I posted. And one final thing I wanted to say about my HISE experiments, I want to go back to one of our previous meetings when I discussed hybrid sampled and synth instruments. And as you saw, maybe you noticed that HISE is perfectly capable of doing that. You can fire up a sampler and the synth at the same time. And also the waveform generator that I used in my synth is capable of mixing two waveforms together, so it can do FM synthesis. So what I'm thinking is that thing I had demonstrated where you can create a crossfade between a synth and the sample. So I'm thinking for just for an experiment, I could create a car plus strong type synthesized string, and also a sample of a guitar pluck. And I could crossfade between the two, so the attack is synthesized and the sustain and release are a sample. So it would be interesting to see how it works, because the transients would be synthesized, so it means they would fluctuate. They would be less boring, more realistic, I guess. And then the sample would give the rest of the realism that the sound needs. And also the convolution reverb to top it off.
Yeah, I remember when you first mentioned this idea. Yeah, I'm interested in listening to that. All right, so that's all from me. My update is that, the electronic stuff. I will continue tinkering with things. And as for the C++, you all know I'm working on the auto mixer in JSFX first. The C++ version will come, but not right now. This will continue to be a C++ study group. I will get back to C++, I promise.
You could create an analog auto mixer.
Well, I think, well, first of all, it exists. Of course, it came to be in the analog world. And of course, I can do it for myself. I don't think I would be able to sell that. There is a patent on auto mixer. I'm not even sure I should be using the auto mixer keyword here. I think I should be using the gain sharing algorithm word, because that's, I think, the non-copyright version of the effect.
Okay.
But I'm not making money from it, so I think it should be okay. And if they want to, I would be honored to receive a complaint from Dan Dugan and asking me to rename my stuff. But yeah, I could do an analog version of that. It could be kind of fun. It is not terribly difficult from an algorithmic perspective. I have no idea how to do that in hardware, but it should be relatively simple to do in hardware if it's relatively simple to do in software. I don't know.
Oh yeah, and I think that the guy
Not
from
always.
the YouTube channel White Sea Studio, I think he also created his own compressor or something. I think he also tinkers with hardware from time to time.
Yeah, I think he built a kit based on Giraffe. Is that how you pronounce that? I have only seen that name written down, but it is a sort of a glue compressor. So it's more like a SSL kind of compressor that you can buy the PCB and then you have to buy all the components. And I guess some people sell kits for that. Yeah.
Oh, sorry. Speaking of SSL, I think there is a mixing board or console called Ghost. I don't remember the company, but it's way cheaper than the SSL, and they're actually selling an expansion kit that if you plug it in, you get a similar sound to the SSL board for a fraction of the money.
Interesting.
So maybe you could do this. Maybe you could create cheaper. You can be like Behringer, you know, the reverse engineer things, and they sell them in a lower price.
No.
No, don't do that.
I'm not into that business. No. Mage says this was great. You could study the depletion layer in transistors and Zener diodes. What about them? What about the depletion layer? Because I know what they are. I just don't know what you're talking about specifically. Anyway, how about we wrap this up?
Yep.
All right. So thank you very much, Fotis and Cwits, for joining me on the call. And thank you to everyone else who was on the chat, Mage, Bo, Tail, everyone who is watching this who is not on the chat or on the call. I also appreciate you being here. And I'm looking forward to seeing you again in 2 weeks, probably on Wednesday, for the next meeting of the C++ Digital Signal Processing Study Group. Do you all have final words?
Thank you.
Thank you all.
Thanks. Bye.
Bye, everyone.
Bye-bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.